So these are the concepts we discussed last week. Apply transformation, translation, rotation, scaling. Then we created a class for creating 3D object. And today we are going to continue with setup color attribute. And one more additional thing that is really very important for the assignment 2 is creating multiple objects. So we are going to create multiple cubes. And so if I go to the geometry from last week, we have a cube, we have a triangle, and geometry is the superclass, right, for both of them. So we are creating cube and triangle from the superclass. So we are going to do multiple 3D. Let's say 3D because even the triangle is 2D. We define that as a 3D object. So multiple 3D objects. Okay, so let's start with the color first because that is really important to see the proper cube. So let me go back to the code and then I am going to translate it back to the origin. Right? So this is the place where we translated. So if I make this 0, it will be back to the center, right? So this is our cube. I can rotate it, but it will not see it well because of not having the separate color on different faces, different sides. So practically they will look the same. But still, eventually you're going to rotate that. So I can go ahead and add the rotation here. So I think we tried this last week, but still. So I need to do, let me go back to the geometry to see what functions we have here that we can use. Okay, so we have this rotate. So let's consider we'll rotate alongside the y-axis. Okay, so we're going to use this rotate y, and only parameter we need to supply is the angle. So let's say we want to rotate by 45 degrees alongside the y-axis. So this is our rotation operation. Let me delete the spaces because they are pretty much similar type of code, right? And then now we need to, so we can see we're multiplying the model matrix with the translation matrix and the scaling. But we also need to rotate the cube. So we need to apply the rotation somewhere, right? But I didn't apply any rotation, as you can see. So what I'm going to do, I'm going to add here. So we have some missing semicolons here. I'm going to add this rotation matrix here just after the translation. Okay, so this is a rotation matrix. I'm making sure that the spelling is correct. So this was my rotation matrix, and that's what I'm multiplying with the model matrix. Okay, so let me refresh and see if the rotation by 45 degrees is working or not. So here we go. So you can see something changed, right? So this is actually side of the cube, but since we don't have different colors, it's not working as expected, right? So let me go ahead and introduce you how to add color, which is our next topic in the concepts. So we are going to set up a color attribute in order to do that. So let me simplify this shape first, because we're going to make some changes to our geometry. So we have a cube. Let's open both of them. And we have a triangle. So what I want to do in the original cube, you see the comment, I have this line, so with the red color, with green color. So that means I want to have the colors here, right? So in my objects, the first three elements should be position, the second three elements should be colors. So this is exactly what I want to have for both of uh, for all of my objects, right? Okay, so let me first change the triangles. So let's have some separate colors for each of the corner of the triangle. I do not have multiple faces for the triangle, but I have different corners. You'll see if I have separate colors in three corners, there will be some interpolation effect. So let me add, maybe start with red. So this is red, and then this is, let's make the next one green. And then the next one blue. So green would be 1 here. This is 0. Blue would be 1 here. This is 0. Right? So this is what I want for the triangle. Okay. So yeah, probably I should have draw the triangle first to make sure. I can still do that. I have some typos here. I think now we are good. Okay. So what if I delete this? I'm deleting the color just to draw the triangles. I'll bring them back. And then I replace the cube with a triangle. That would be one simple line, right? So this is a cube. I'm going to replace that with a triangle where I declared the cube. So new cube, let me make this a triangle. Even though the name is cube 1, we should see a triangle on the screen now, as you can see. Also, I want to scale up the triangle. So my cubes are starting from 1 to -1, or -1 to 1. My triangles are 0.5, so let me make them 1. Okay, I'll do that later. First, let me bring back the colors, right? So if I try to draw the triangle now, you can see something broken because of the extra data I have here. So we are going to do the same for the cube, but let me first fix this thing. Also, let me remove the operations here. So we have this rotation. I don't want to do any rotation now. I made the scaling much smaller. Let me scale it to 1, or no scale at all, right? And no translate, because I want to see the full size of the triangle. So now you can see still broken because we added the color, but we never added the color attribute here, right? So here we're going to set up the color attribute. Okay, so to do that, what I'm going to do, I'm going to add some new lines here. So for now, we have only one attribute location, which is a position, right? And then I have this vertex attribute pointer, which I'm using to send my a positions to the shader, right? But now I want to have color for my triangle, so I want to add one more attribute. So this is not correct anymore, so I'm deleting this, but I'm going to add one more attribute, which is this one. And I'm going to call this a color, because now the colors are going to be an attribute instead of uniform variable. So our original color was uniform variable, and in that case we can only use one color. because the uniform variable is one variable that is going to be applied to all the vertices. So I'm going to save it as an attribute, then bring it here in the A color, and then I have to pass the color to the fragment shader, right? Because fragment shader deals with the color. We have this U color uniform which is coming from the CPU side, but now we don't have we don't want to use uniform color. So I'm going to use a varying vector for the first time, and that is going to be for communicating or transferring the color from vertex shader to fragment shader, right? So in the vertex shader, I'm creating this varying vec3, and I'm calling this v color, varying color, right? And then I'm going to create the same variable also in the fragment shader here. I'm not deleting the uniform color right away, because if I delete that, we'll not see anything on the screen. Maybe that is better, right? We are not going to use that. So removed that. Then I'm going to remove the uniform color here. And if I try to refresh this, you'll see there is no color here, right? Because this, we're not passing any color from the CPU side. And remove the uniform from the GPU side or in the shader. Okay. So we have to add one more line. That will be useful once the colors are here. So we don't have a frag color. We don't have a U color. U color is not even defined now. So I'm going to call this V color. But V color has nothing, right? So V color should have the attribute color, which I should get from the vertex shader, right? So I'm going to use V color, and then I'm going to assign my A color here, right? So our shader is mostly done now, but what missing is I don't have a color here. I have the A position and everything for that. I don't have everything. Don't have anything for A color, which is going to be exact copy of A position. So I'm going to copy this thing and then replace all the A position with color. So A color, and then here and here. So we have an exact copy of A position. And so if you remember from last week, this is how you're going to use the value from our data, right? So our data is coming from our buffer, and our buffer is we're binding our buffer with the triangle class, right? And in the triangle class, for each point or each vertex, we have 6 values. The first 3, they are floating point numbers, but they are locations or positions, vertex positions, right? And these 3 are the color. However, we never defined that here. So this is something we're going to do. We're going to say we have 6 values per vertex, and out of the 6, the first 3, starting from 0, first 3 values are going to be the position, and then we'll have again 6. We'll start with 3, and then the next 3 is going to be the color. So how do we do that? We know that we're going to use float, and we need to know the size of the float, which vary depending on the machines. So what I'm going to do, I'm going to define a variable to know the float size, right? And instead of memorizing the size or looking at the size, I'm just going to use a line of code that will give me the float 32 size for this specific platform. So I just need to know bytes per element, I think. And then I should have the value here. And I'm going to use this variable here. So I said we have 6 values for each attribute or each vertex, which is true for both of them. Starting from 0, the first 3 are going to be position. Starting from 3, the next 3 is going to be color. So I need to say that here. So for the first one, I can keep it as it is because we're starting from 0. So 0, and here we are starting from 3. So 3. So this is ultimately 0, but just to make the format consistent, I am using the same format for both. Okay, then. So we are mostly good, except you remember that instead of using each 3, now we need to use each 6, right? So we need to divide the vertex length with 6. To be more clear, so now we have 18 of them, right? And the 18 values are representing 3 positions or 3 vertices. So we need to divide the 18 by 6 to make it 3 vertices. So I'm going to change that here with 6. Let me refresh and see where we are. Okay, so looks like we did it in the first attempt. So we have this triangle with this interpolated color. So this point was red, this was blue, this was green. So we have this multicolored triangle, which is also nice. Okay, so let's try to do the same for the cube. So we have this cube class here. Now we need to add color for each of the points, right? And how do we do that? We said first one is red. And this face is completely red, right? So how can we do that? Let's try to copy. So this is red, we know, right? Then okay, so this is green. So let me copy it one more time. So green should be 1. And then I'll blindly copy. This one should be blue. So changing it first time and then blue, 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 and blue. So we have 3 more. I can just assign some random combined color here, right? So let me copy this and then I am going to replace this with let's use so this is green and blue. So the combination of green and blue. Let's use a different combination here, red and green. And we have one last combination left, that is red and blue. Okay. So I think we are good with the colors. Now we only need to make sure that we are seeing the triangle right. We're seeing the triangle right. We're seeing the cube as we want to see it. So now I am going back here and changing the new triangle to cube, and hopefully everything will work. Okay, so we have a full cube, right? Because we didn't scale the cube, it looks full. So let me go ahead and do some scaling here. Okay, this was the place where we wanted to scale it. So I'm scaling it to half, and if I now you can see only the front side of the cube. So the front side was colored using, this is the front face, right? So we have this combination of red and green, which is this color. Now let me quickly rotate the cube and see if we can see multiple colors, because rotating will show us multiple faces, right? So you can see the front face and the side face, which is blue. So if I even rotate more, maybe let's do 135 degree. And if I refresh now, did I say? Okay, 135 degree. What is that? Let's try negative 45. Yeah, negative 45 is showing me a separate color, right? Let's use another axis maybe. So now we can see different sides of the cube. So now we know how to apply the color attribute to have separate color on the object, on the 3D object, right? So that concept is done.